Go ahead and talk about some triangles. Okay, and so let's go ahead and look at this slide. Triangle classifications. We have an acute triangle. What can you tell me about an acute triangle?
Its angle is less than 90 degrees.
Yeah, so all angles are less than 90 degrees. We've already discussed the acute angles. Okay, so this should be nothing new. All angles are less than 90 degrees. Okay, what about an obtuse?
More than 90 degrees.
One angle is more than 90 degrees. Okay, one angle is more than 90 degrees. Okay, now why can't you have more than one angle?
So it won't equal 180.
Then it won't equal 180. That's right. Because remember, in a triangle, the sum of the measures is 108 degrees. In a right triangle, one angle, exactly one angle measures 90 degrees. So once again, like I said, these should be reviewed. You should know these pretty well. So anyway, what about a scalene triangle? What can you tell me about a scalene? All sides are different measures. And consequently, with all sides being different measures, all angles will be different as well. Okay? Did I roll my nose?
I hope you didn't. I truly hope you didn't.
Alrighty, so let's go ahead and talk about an isosceles. What about an isosceles triangle? Two sides are the same. Two sides are equal. Equilateral? All sides are equal. And so if you've noticed up here, we've broken down triangles on the top here by angles, on the bottom here by sides. So on the top here, these are classified by angles. On the bottom, they are classified by sides. So consequently, we can classify a triangle as one of each. So we could say we've got an acute scalene triangle. Okay. We could say we've got an obtuse isosceles triangle. So on the top, these are angles. On the bottom, these are sides. So that's important to understand that there are two ways to classify triangles. So let's go and see what we have next. If the triangle is equilateral, find the length of h. If the triangle is equilateral, find the length of h. Evidently I have some problems with some font there, but that should say of h. So if it's equilateral, does anybody remember what all the angles are? Yeah, all the angles are equal, and since all the angles are equal, they all have to be 60 degrees. So that means every angle in the triangle is 60 degrees. So up here at the top, that's supposed to be 60. But if I divide it by 2, what I've done is I've created two 30-degree angles. Okay. And so really, what can you tell me about h? Not necessarily what the length of the side is, just in general, what can you tell me about this segment? Yeah, it's what did you say? It has a 90-degree angle. It's actually the height. Okay? And so what I end up having is a right triangle. So there are two ways to solve this. The first way is to observe it's a 30, 60, 90 triangle. Okay? And we know that there are some relationships between those. But you get to a test and you forget. The other way you could solve this is to use the Pythagorean theorem. So it doesn't matter. Okay? If you recognize it's a 30, 60, 90 triangle, your answer, h, should be 10 root 3. Because it's your shortest side times root 3. But you get to a test and you freak out and you're like, oh my goodness, what do I do? Let's use the Pythagorean theorem and I'll show you that you get 10 root 3. Oh, let's try that one again. Okay, so here I have h squared. What's 10 squared? 100. What's 20 squared? 400. So what do I get h squared to equal? 300. So then now to solve that, what are you going to do? Take the square root. Okay, so now what I'm going to do is break down 300. So if I break down 300, I can break that down to 3 and 100. And what can you break 100 down to? 10 and 10. There's your pairs, which is exactly what you wanted. There you go. And so you have 10 root 3. So either way, you can get there. It's just that the second way, if you don't recognize it, is a little bit more work. Okay. So remember in a 30, 60, 90 triangle, the side opposite 30 is always half the hypotenuse. Side opposite 60 is always root 3 times the shortest side. So if the triangle is equilateral, find the length of h.
Did we just do an equilateral one?
Yep. So we just did an equilateral one, so we could go through and label. Here's 60 degrees. Here's 60 degrees. We know this is perpendicular. This is 30. This is 30. So what is h? 10. Because in a 30, 60, 90 triangle, the side opposite the right angle is always double the side opposite 30 degrees. So here what I'm going to do is take 5 times 2. So h equals 10 centimeters. Just for kicks, what would this vertical distance be? 5 root 3. Good. So just for kicks, this is actually 5 root 3. It's always your shortest side times root 3. Another thing to keep in mind when you're doing this, generally, they've got multiple choice questions. So if you've got a 30, 60, 90 triangle, chances are it's going to be something with root 3 and not root 2. So they're going to kind of throw those in, and you'll see that when we do a practice test. So if the triangle is isosceles, find the length of h. So isosceles triangle means what? 2 sides are the same. So I've got 6 inches horizontally. What else do you know is 6? The vertical, yep, this one. So I'm going to tell you right now that in a 45, 45, 90 triangle, the hypotenuse is always root 2 times the length of the legs. So in this case, h should be 6 root 2. But once again, you get to a test and you panic. And you're like, crud, I don't remember. So easily, we can do this Pythagorean theorem. 6 squared plus 6 squared equals h squared. So if you forget, that's still okay. So 6 squared is 36. What is 36 plus 36? 72. So then now to solve that, what do? Square root. And so you can break this down. 2 and 36. 36 is 6 and 6. So if I take my pairs out, I got a pair of 6s. So it'll be 6 root 2. And that's exactly what I got up above.
So, for the Pythagorean theorem, you have to put is there like a certain order you have to put that in?
Yep, the 2 legs, and then they will always equal the hypotenuse squared. Remember, it's legs squared plus legs squared equals hypotenuse squared. All right. So we can remember that in a 45, 45, 90 triangle, the hypotenuse is root 2 times the sides. Or, let's say we forget. What's that vertical distance also? What's this vertical distance going to be? Which is what?
Half of the
Which is h. Okay. Now see, why did I do that? Because now in our Pythagorean theorem, what is that going to look like? Yep. H squared plus h squared equals 12 squared. See, there was a whole point in doing that. Because now, what's h squared plus h squared?
H.
Let's think about that. What's x plus x? X plus x is always 2x. H squared plus h squared is 2h squared. Okay, equals 144. That's what 12 squared is. Now what do? Divide by 2. So I get h squared to equal 72. What do you do now? Yep. If you didn't right here, we just did root 72 on the page before, so we already know that that's 6 root 2, and that's going to be your answer. The other way you can go backwards is that instead of taking h times root 2 to get 12, we can take 12 divided by root 2. And if you do that, you'll end up getting 6 root 2, because to simplify this, you get root 2 over root 2. So you end up getting 12 root 2 over 2, which is 6 root 2, which is exactly what we got there. In a 45, 45, 90 triangle, the relationship always deals with root 2. In a 30, 60, 90 triangle, the relationship always deals with the root 3. And that's kind of what I was explaining on the time before that. So let's go ahead and look at this. The vertices of a triangle. The vertices are. Good job. That should be R, by the way. Okay? You're getting a little bit of a grammar lesson, too. The vertices of a triangle are -1, -2, 3, 4, and 7, -2. And they're asking, what type of triangle is it? So we want to know, what type of triangle do I have here? So let's double check. This is what I told the kids to do last year. Okay? First of all, if I count here, let's count horizontal. What do I have horizontally here? I have 4, right? What do I have vertically here? 1, 2, 3, 4, 5, 6. So what do I have horizontally here? 4. What do I have vertically? 6. Okay? Here, what's the distance between these? 8. 1, 2, 3, 4, 5, 6, 7, 8. So this one, the distance is 8. So now, in order to classify this as a triangle, okay, I need to know the relationship between the sides. So notice, I've either got an isosceles or a scalene. So I either know 2 sides are the same or no sides are the same. What can you conclude here? 2 sides are the same. Why? Because of the 4 and the 6, right? They tell you. So you know 2 sides are the same, so boom, we get rid of those. So now you need to determine, is this an acute triangle or is this a right triangle? Yeah, obviously you can see that this isn't going to be a right angle here. I mean, there's no way that that's a right angle. Okay, if you wanted to, we could go through though and show by the Pythagorean theorem. Okay, or you could just recognize. So this is actually an acute isosceles, A. Biggest thing, eliminate anything that you can. Okay. That's the biggest piece of advice I can tell you. All right, let's look at another one of those. Okay, find the measures of the missing angles. Okay, so when I say find the measures of the missing angles, I'm looking for ABE, AEB, angle C, and angle D. So I've got 4 angles I'm going to try to find. And so we're going to utilize all that information we learned about parallel lines last year. Learned lots of stuff about parallel lines. What? I bet you didn't, because I bet you can already start and tell me what one angle is.
The one down D.
Don't neglect, there's an obvious one, and it's on the right side. What's this angle right here? So that one is ABE. So ABE is 50 degrees. Why is that 50 degrees?
Because on the other side of the line it's 130.
Yeah. A straight line is 180. You've already used 130, right? So this is 50. So now what'd you say? Okay, so AEB is 75 degrees. Okay, because you've got a triangle. Triangle is 180. With that in mind, what is angle C? C, right down here. What? 50. Why is it 50? Yep. That's the same as the angle B. And then what is D? D is 75. Good. Good job. So far, so good? All right. Find the volume of each of these figures. What's the volume of that figure? What do you think you're going to do? Yep, exactly. Exactly if you didn't hear what Laura said, length times width times height. So in this case, 5 times 4 times 12. Now if you forget, they've got the formula for volume. They've got a whole section on volume on that reference sheet that you have. But what's 5 times 4 times 12? 240. So 240 centimeters what? Cubed. Good. All right. Now this one isn't a square, so we have to remember how we do this. To do this, if you look at your formula sheet, does it have a triangular prism at all? No, what does it say? It just says a right prism at the very bottom, where it says B, big B times H. It says big B times H, where big B is what? The area of the base. So I need to find the area of the base, and I take it times the height. So here's the area of the base right here. Base is what shape?
Wait, isn't the base the bottom one?
No, the base is actually the shape that's repeated. And if you notice, I've got a triangle on the front, I've got a triangle on the back. That's the base. Okay, my height in this triangle is the 1.
I just always took the base.
No. So, shape is a triangle, right? So the area of the base will be 6 times 4 divided by 2. So what's the area of the base? 12. So I have 12 times my height, which is 1. So what's my volume of the prism? 12 feet cubed. All right, let's see what we got if we've got one more. Or if that's just the sheet. Yep, one more. Area of the base times the height. Area of the base times the height. Now, obviously, since you aren't going to be able to use calculators, they're going to want you to leave your answer in terms of pi. So what is the shape of the base? What's the shape of the base? A circle. And so I know the area of a circle. So volume is the area of the base times the height. I know that the area of the circle is pi times 4 squared, because 4 is my radius. So what is 4 squared? 16 pi. So that's what my area of my base is. So my area of my base right here is 16 pi. What's the height? The height is right here, 9.5. So in order to solve this, what you need to do is, first of all, you're going to see what your answers look like. Chances are they're going to have pi in them. So I'm going to need to take 16 times 9.5. Okay? And then we'll just attach it to pi, yep. So 16 times 9.5, you get 8. Okay, 4, carry 5, I get 14. So what do we got? 0, 2. So my answer will be 152 pi centimeters cubed. And there you go. So now, you've got this is kind of a hodgepodge worksheet of quite a few things. So I'm going to go ahead and pass it out. Okay. What? No, you can use that sheet. You just can't use your notes. So for tomorrow, the NeSA practice number 3.